Hey guys, it's Mr. Stark, back with a familiar circuit that we did last week. I got to make this kind of quick. This is kind of how we add and manipulate circuits. Something I wanted to give to you a little bit before advanced motor controls, or in other words, the course called Logics Part 1, where we do a little more difficult circuits before we go into PLCs. So, with that being said, we have the compressor circuit. This is the air compressor circuit, and as you might remember, that's a symbol for a pressure switch. That's the symbol for a flow switch. It looks like a sail, it looks like an oil can. What we have are two motors in this, a lube oil pump motor, which pumps oil into the compressor, and a compressor. So most of us know how an air compressor works. We go in, we hit the reset button on the machine outside the gas station. CR becomes energized, that closes, that closes, that closes. We get a drop in pressure, allowing that contact to close. Then it energizes the lube oil pump. That pump starts to pump oil. Once, remember, this contact is closed, the oil's pumping. Once that oil flow hits the switch, it'll close this switch. Right now it's hearing the alarm, but it'll close this contact, energizing the compressor. Compressor will run until we have a we have a complete circuit. So compressor runs and running through them overloads. The interesting part is this: if the lube oil pump trips on overload, this will open and not allow the compressor to work because it needs to take that path to get home. The reason why I'm making this video is because in our lab, if we want to simulate this, we don't have relays that have 3 sets of normally open. All of our relays have 1 set of normally open and 1 set of normally closed, or 2 opens or 2 closed. So how do we make this work in lab? Well, a couple different ways. We could eliminate this other contact and just draw 1 line, or the best way of doing this is to make this a little more interesting. We used up this open contact. This would be 9 and 5. And we used up this contact, and in this case, this could be 12 and 8. So those 2 open contacts on that 1 relay CR are used. So in order to make this more effective, we could add another relay, and this might just make it in here. So when CR gets energized, it's also energizing another relay, and if we put this in parallel with that one, you kind of see where I'm going with this. Try to draw this in here, just sneak it in there. We're going to call this CR1. So when CR gets energized, it's also going to energize CR1, but we got to rename this one. We're going to rename this one, CR1. That allows me to use those contacts on that relay, and I could start over again, so I can put a 9 and a 5 here. That took care of that problem of not having enough open contacts on 1 relay. So how do we fix that? We add a relay in parallel with the one that was already there, and we rename that contact. So you can kind of see how that works. The next thing we want to do is be able to add to the circuit an indicating light when the lube oil pump is running and when the compressor is running. That's simply just by extending this line. We would want to add that light in there. We extend this line. We come across here. This is how a very simple way of adding a circuit. And what we're going to do now, we have unswitched power on the left, which obviously is there for us when we need it. We're going to then make those open contacts. We will call this LOP. We'll call this contact compressor, because once that coil energizes, I'm going to steal that auxiliary contact. And because we already have a red warning light, I guess what we'll do here is we'll take a green light. Oops, excuse me on that. A little bit messy. We'll add a green light. This green light will represent lube oil pump is running, which is just to give us an indication. And we could certainly do blue, I guess, because that's the only color I have left. And we're just using the contacts that are likely on that relay base or starter auxiliary contact to give us an indication. So if we wrap this up, when the lube oil pump is energized, we know once that energizes, the contact associated with it will close, giving me my lube oil pump light. We also know that when the compressor is energized, that will close, giving me my compressor light. And if I don't have oil flowing, this will drop back into its position where there's no pressure against that sail switch, or flow switch rather, and it'll give me a warning light. If oil is flowing, it's understood that that's a good thing, that this contact would close, giving me the compressor. We need oil for that to flow. You remember the sequence, we wrote it down last week when we were messing around with this circuit, and this is how we can add to it and make it a little bit better for the purpose of our lab. So, simple way of just being able to add to a circuit. We will add more to this. We're going to add another button, and we're going to turn all this into 120, and we're going to have a 24 volt start to get this going. That's it. So hope you enjoyed this video, and see you at the next one.